Hi guys, today we're going to write equations for parallel and perpendicular lines. Now, we wrote equations in class already, but we wrote equations given either a graph, given a point and a slope, or given 2 points. Now I want to look at, okay, I give you some information and I want to write an equation of a line parallel to it or a line perpendicular. The first thing that would be good to understand is what parallel and perpendicular lines are. Hopefully you remember, parallel lines are two lines that never cross. Perpendicular lines are two lines that cross and form right angles. But more importantly, I want you to investigate the equations of this line. So look at the side on the left there. Parallel lines, yes, you can visually see that they never cross, but look at those two equations on the bottom. They have something in common. What they have in common is their slopes are exactly the same. So parallel lines have the same slope. Now, perpendicular lines, if you look at their equations, their slopes are not the same. So I have a slope of 3 and a slope of negative 1/3. However, they do have a relationship. Their slopes are what we call opposite, meaning one's positive and one's negative, reciprocal, meaning they are flipped versions of one another, like 3 or 3/1 and 1/3. They are opposite reciprocal slope. Okay, so we are going to utilize these two concepts based on what we know with writing equations to do this today. So if I look down at the bottom, it says I want to write an equation through the point 4, -1 in parallel to this given line. Well, this is right away you see the word parallel, and that has to know to you that that means the same slope. So whatever the slope is of the line given, you want to create the exact same slope. So the slope of the line given is 3/4. So the slope I want to use is also 3/4. Okay, once I'm here, this is exactly like what we did in class. I have the slope, I have a point. I'm going to utilize slope or point slope form through everything that I do just because that's my personal preference. But as I mentioned in class, if you'd rather plug everything in and find B and go about it that way, please know that's totally fine. So I'm going to say y minus my y value, which becomes y plus 1, equals my slope times x minus my x value. I distribute that slope. I get 3/4 x minus 3. I get y by itself, and I end up with 3/4 x minus 4. There's my equation. The two lines have the same slopes, so I am confident they're parallel. If we graphed them, they would never cross. Okay? Now in contrast, look at the next one, number 2. Through the point -4, -3, and perpendicular to y equals 9x minus 1. So perpendicular does not mean the same slope. It means opposite reciprocal slope. So look at the slope of the given line. The slope of the given line is 9. Its opposite reciprocal is -1/9. So I have my slope, I have a point, I'm ready to go. I'm going to say y minus my y value, which becomes y plus 3, equals my slope times x minus my x value, which becomes x plus 4. Distribute on the right-hand side, which gives me -1/9 x minus 4/9. I know you don't like those fractions, but we can deal with this. Get y by itself. And I would like you to leave this in fraction form, not make these decimals. Now I need to think about this. If I have -4/9 minus 3, I need to think about what that means. 3 as a fraction over 9 is 27/9. So -4/9 minus 27/9 becomes -31/9. So there's my equation in slope-intercept form. Again, the lines are perpendicular. All right, let me get you started on the third one and then let you try it. Number 3 says that we are through the point -5, 1 and parallel to that given line. Now, the problem about the information that's presented to you is that the equation of the line is given in standard form. Standard form's great, we discussed it last week, but it doesn't tell me anything about slope. I need to be in slope-intercept form to make determinations on the slope. So before I can do anything else, I need to get this equation in slope-intercept form, meaning I need to get y by itself. So that has to be my first move, to subtract the 3x. And then divide by 10. So in slope-intercept form, this looks like negative 3/10 x plus 2. Now I can tell you about the slope of that line. The slope of that line is 3/10. We want a line that's parallel. So that means we also want to use a slope of negative 3/10. I gave you the point up top, it was negative 5/1. So hopefully I can utilize this information and write the equation. So pause the video for a second, see if you can write the equation, and then check your work with me. All right, so how'd we do? Hopefully we agree. Okay, once I had the slope and the point, plugged in my y value, plugged in my slope, plugged in my x value, I distributed the negative 3/10, and I got y by itself. Again, I would prefer that you kept these in fractions instead of translating to the decimal counterpart. Okay, look up at number 4. So through the point 2, negative 6, and perpendicular to x equals 5. All right, this one's kind of a funny one. It's a special case, so to speak. If I'm perpendicular to an x equals line, x equals lines are vertical lines. X equals 5 is a vertical line through 5 on the x-axis. Now, the only thing perpendicular to a vertical line is a horizontal line. So horizontal lines are y equals a constant, a y equals line that goes through the y-axis. So all I have to do in this case is look at my coordinate, 2, negative 6, see which one's the y value. That happens to be negative 6. So the line perpendicular here would just be y equals whatever my y value is in this point, which in this case is negative 6. So this one was a slightly special case because we were talking about special lines, meaning vertical and horizontal lines. Okay, flip on the back. So number 5 says through the point 2, 3, and parallel to the line through 2 other points. Okay, again, when you see the word parallel, you need to know that that means something about slope. Parallel lines have the same slope. So my first job is to find the slope of what's given. Well, all I have is 2 points, but we did slope in class on Tuesday. So we know how to find the slope between 2 points. I'm going to say y2 minus y1 over x2 minus x1. That gives me my slope as a positive 2 over 3. Now, if my line is parallel, I want to use that exact same slope. So I want to use that slope of 2/3. And my point is 2, 3. Lots of 2's and 3's. Okay, again, pause the video, see if you can find this equation, and then check your work with me. All right, let's see how we did. Hopefully we agree. Plugged in my y coordinate, plugged in my slope, plugged in my x coordinate, and I ended up with y equals 2/3 x plus 5/3. Okay, now, these next 2 questions, I'm going to have you actually try them, but I do want to give you some hints about it. So if I look at number 6, 6 says which lines are parallel. So you got to know parallel means same slope. Okay, so hopefully you can look at A and C and readily know what their slopes are. B and D are a little bit different because you're not in slope-intercept form, you're in standard form. So the first thing you need to do is find the slopes for B and D, and then you can determine which 2 lines are parallel. And then on number 7, it says the line passing through which 2 points, I should say points, is parallel to the given line. Okay, first you have to take that given line and put it in slope-intercept form, because as it exists, it's in standard form. And I can't tell you anything about the slope, why it's in standard form. So if I get that line in slope-intercept form, I'll know what the slope is. Then, if I look at my choices, they're just 4 sets of ordered pairs. So what I'm going to have to do for all these choices is I'm going to have to find their slope to see which one is the same as the line. Okay, so go ahead and try those too. And I'm not going to put the answers on the video. We'll check those in class tomorrow and bring any questions you'll have. Thanks, guys.